And now take your calculator and see if you can calculate what v is. You want to get this whole side, multiply by 2, and then square root. Calculate that. Calculate it. I'm going to do it with the 250 crossed out because I'm lazy. So I'm getting this side is and then times 2 square root of that. Yeah? You can solve this problem, all of these types of problems, you could solve it by saying that this thing is pointed straight down, that it's actually headed straight down or straight up, right? And use kinematic formulas to solve for the final velocity. It's possible to. But this is just another way to frame the same thing. This velocity was the unknown velocity of the cart at the bottom of the hill. Huh? 4.5 squared, that's the velocity at the top of the hill, right? So the left side is the top of the hill. So these problems, you can always set them up as before and after, right? But the only thing that doesn't really work so well, so in this problem, for example, the top of the hill is before and the bottom of the hill is after, right? The only thing that doesn't work so well is that sometimes you have forces and the forces act all the way through the problem, right? So what you do then is you categorize them this way. If the force speeds you up, okay, if this thing speeds you up, put it on the left side, it's an asset. So if it's me pushing the bowling ball away from me, right, then that's a speeds you up force. If it's something that slows you down, like a friction force or a puddle, like in the next problem we're about to do, right? If it slows you, put it on the right side, it's an expenditure of energy. Everything else is just, if you can draw the picture, you can pretty much get the what's happening, right? So let's do one with a force and a distance. This is the Fred Meyer parking lot, right? And it's got that big puddle in it, right? And what do we do with that puddle? Well, the question is, are you the person that has to pay for the catalytic converter on the car you're driving, or is it someone else that has to pay for it? Okay? And I think I used to hit that puddle with great gusto, but then I cracked my catalytic converter. It is a thing that burns the unburned gasoline from your engine, and it costs $800 to replace a catalytic converter, and it glows red hot, and if you immerse it suddenly in water, like big puddles like that, not so good for it, right? So now I drive around that puddle, you know, so there we have it. But let's suppose an 890 kilogram car is going 6.2 meters per second before the puddle, and the puddle, somehow we know that this puddle exerts this 3,200 Newton force of friction or something on it, and it's 3.6 meters long, right? The question is, what's the speed after the puddle? What's the velocity after the puddle? So what's before? Where's before? Is before the puddle? And after the puddle? Yes, it is. There we go, right? What do we have before? Do we have any mention of a force speeding this car up? No, not so much, right? Okay. Is it on top of a hill? Oh, it looks level to me, right? Okay. Is there any mention, is it moving before the puddle? That's the only asset we have, right? So we have kinetic energy. We've got 1/2 890 times 6.2 squared. Okay. Afterwards, let's just go through them all. There are 3 doors, right? Is there mention of a force slowing this thing down? Yes. Okay, so we fill in what we can. We know the force and the distance, right? So 3,200 newtons times 3.6 meters. Does it go up a hill? Is there any mention of it going up a hill? No, but if it did, we'd be ready for it. You know, we could deal with that, but there's not, right? Is it moving afterwards? Yes, it is. There we go. So I'm going to fill in what I know. And of course, the thing that I don't know is the velocity, because that's what it's asking. It would be sort of silly if they told us the velocity and then asked us what it was. Although that would be funny, because you'd be like, oh, is the answer right there? Okay, this is higher mathematics, isn't it? How do you solve this thing? Do you go this minus this first? First off, can I cancel out 3890 from all these? Can I? Not from this one, though, right? So if you can't cross it out of all of them, don't bother, right? Because the answer will have that in it, unless you like to do that. So what we do mathematically is I'm going to go this minus this and set it equal to that. So try to do that. Take your calculator now and try to do that. So I took my answer that I have on the board right now so far is this minus this is equal to that, right? And now I'm going to multiply by 2, divide by 890. And now I need to square root both sides. Yeah? Does that make sense?
Really?
No. No. So much learning. I'm so sorry. Next time is your brain vacation. 1, 2. Yeah, Carly.
I'm at the end of my day stretch today.
Yeah.
Run out of juice here.
So what I do is I do this minus this. Is that right? Isn't that right? So 0.5 times 890 times 6.2 squared, right? Minus 3200. This minus this is this, right? Isn't that true? Yeah. So I did this guy minus that guy, and I get this, right? Yeah, yeah, yeah. Right, and now you're set. Now you can times 2 divided by 890. You can do that, right? But remember, this is plus that, right? That term was plus that, so you should have ended up with a something equals something plus something, right? Look like you combined them, which is illegal because it's got a v squared, yeah? Huh? Yeah.